Hello, my name is Tyler Hoy, and this is my Managing a Professional Engineering Project presentation. Introduction. Just before we begin, I wanted to address if there's any questions. I'll be taking any questions at the end, so please save them to then. I've been approached by GJ Chemical to create a new updated production system. They have requested that I update their old inefficient system with a new, more reliable one with increased production capacity. They have given me a list of features which they want included and have also given me a budget for the project, but they have given me freedom to create my own designs. GJ Chemicals current system works by filling a 1,000 litre tank by pumping in 800 litres of compound A, then mixing in 200 litres of compound B, making 1,000 litres of Formula Z. When the tank is filled, it is replaced with an empty one, and the process is repeated. The company wants a new design which will maintain a continuous level of increased production while taking into consideration employee safety and budget. The first stage of production is the client brief. The client brief is provided by the client and outlines all of their needs and requirements for their system. GJ Chemicals is a small startup company who work out of a small facility in Northern Ireland. The company's future goal is to grow the business to try and compete with larger companies, but to do this, they will first have to upgrade their production processes. Their current system doesn't work efficiently and isn't up to modern day standards of mass chemical production, so they have tasked me with creating a brand new design from scratch which will help them speed up their production times and streamline their process to allow for constant production with a focus on minimal downtime and a high level of maintainability. The company produces a formula known as Formula Z. They produce the substance by combining two separate substances known as compound A 4 parts and compound B 1 part. Due to the company only being a small startup, they have been very slow and inefficient way of producing Formula Z. They do this by filling a 1,000 litre mixing tank with 800 litres of compound A and 200 litres of compound B, thus making 1,000 litres of Formula Z. This process then repeated. For their new design, GJ Chemicals have requested that the new system allows for continuous production. This also means the production never has to stop and continue around the clock, allowing for a much increased level of production of Formula Z. The company has been very generous and have provided a budget of £25,000 for the design and production of the project, but they have requested that any savings would be appreciated greatly. Planning the project. The next stage of the production process is the planning of the project. So the first part of my planning process was to create an initial production table and initial Gantt chart. These are used to plan what tasks I have to complete and what order I should complete the tasks. This also allows me to make an early estimate on how long I should spend on each task and give me a rough time scale and schedule to try and follow. Now, as I said, these were just initial estimates that I thought in my head. I tried to make them as realistic as possible, but things get in the way when you are producing a project and not everything goes to plan, but I try my best to stay as close to these times that I estimate as possible. Not every task met my production table time frame. Some tasks took longer and some didn't take as long as first anticipated. So because of this, I created a second production table and a second Gantt chart. This was created after the project was finished and allowed me to compare my initial estimates to the real time that each task took. These are the Gantt charts and the production tables that I mentioned in the previous slide. The top two are my initial Gantt chart and production table, and the bottom two are my updated Gantt chart and production table. Project selection. The project selection is broken down into three parts: components, cost, and time. I did this in order to compare my two potential solutions based on these three factors. In the next few slides, I will break down the components, cost, and time for my two designs to decide which is best. Project selection design 1. Components. For my first design, I had to draw up a list of components. For design 1, a flow meter which is used to measure the flow of compound A, two pumps for compound A, two pumps for compound B, two emergency stops, a 4,000 litre storage tank, path A and path B, which leads into a 1,000 litre storage tank which can be removed, motorized trapdoor which can be used to change the flow of solution into path A or B, a safety relay, PLC, HMI, and contractors which are used to control the four pumps and the trapdoor. Cost. I had to also make a cost estimation for each component to make sure my design will be in budget. The client gave me a budget of £25,000, but did request any savings would be appreciated. After calculating how much each part of the system will cost individually, the whole system in total will cost £10,498.80. This means my first design has came in £14,501.20 under budget, which is very appealing for the client. Time. Lastly, I had to make a time estimation for the client. I had to estimate how long it will take to program and how long it will take to install each part. After calculating how long each part of my system will take to program, the total is 70 hours. After calculating how long it will take to install each part of the system, the total is 27 hours. Project Design 2. Components. Again, the same as my first design, I had to draw up a list of components. For Design 2, I will need a flow meter, which is used to measure the flow of compound A, 2 pumps for compound A, 2 pumps for compound B, a safety relay, a PLC, an HMI, 3 emergency stops, contractors which are used to control the 4 pumps, an expanded storage tank of 5,000 litres, and a motorised mixer. Cost. I had to also make a cost estimation for each component in my design 2. Again, I had to calculate my cost for the second design. After calculating how much each part of the system will cost individually, the whole system in total will be £14,450.18. This is £3,951.38 more than my first idea. Even though my second idea cost more than my first idea, it still comes in below budget by £10,549.82, which will please the client. Time. Lastly, I had to make a time estimation for the client again. I had to estimate how long it would take to program and how long it would take to install each part, same as the first time. The total programming time for this design is 70 hours and the installation time is 48 hours total. This is an extra 21 hours to install compared to the previous idea. Managing the project. In this section I will be talking about managing the project. I'll be splitting it down the section into many smaller sections. The first section is time management. Time management is a very key section because you need to give the client a rough idea of how long it will take to complete the design. When you create a time frame during the design process, you have to try and stick to it and keep on schedule as best you can. I found in my experience the best way to do this is to create a production table and Gantt chart, which I can always check back to see if I was behind or still on track with my estimations. Money management. Money management is the most important aspect for the client because they only have a limited budget which I have to work in. They give me a budget of 25,000, which is generous, but I have to make sure I stick to it and make sure I get the client value for money when it comes to the components used. When designing the project, the best way I found to keep track of my budget is to create a table which includes my parts list and a price for each of the components. This is useful because it allows me to see how much the total cost of the project will be and shows how much each individual component costs. Ethical concerns. Thankfully, when creating this project, I never came across any ethical concerns which may have upset the client. When designing the project, I made sure to avoid any ethical concerns because these can upset the client or get in the way during the production process. Positives and negatives. When creating these designs and producing the project, there will be multiple positives and negatives that I have came across. This is very normal when designing a large system for a client who has specific needs and requests. Some of the positives were I was able to create multiple designs for the project myself to the client specifications. I was able to design the project how I wanted to. I was able to stick to the required budget. I was able to maintain an ethical production process. And finally, the client was happy with the design I created and it included everything they had requested. Some of the negatives were certain tasks took longer to complete than estimated. I had problems when it came to designing the HMI system for the project on EasyBuilder Pro. My final feelings towards the project. I feel that overall the project was very successful and I achieved everything that I wanted. I feel that the final project was very good system which fitted the client's specifications and requirements very well. The system was also completed on time and well within budget, which is very appealing for the client and keeps them very happy. During the production we came across a few problems, but we worked through these and finished with a very useful and successful product. Any improvements for the system? I feel this was due to successful planning before beginning the production process. The only thing that I would change for the future is I would try to stick to my estimated times, but that is only a minimal issue as long as the project is still completed on time. Implementing the project. Similar to the previous slide, I was splitting this section down into many smaller subsections, the first being structure. During the planning stage for the project, one of the first things that I did was to create a structure for my project that I would follow throughout the production process. I designed a Gantt chart and a production table to help me follow my planned structure. The Gantt chart and production table outlined the order in which each task should be completed, and which tasks should take less time to complete, and which tasks should take longer to complete. I created an initial Gantt chart and an initial production table for the which outlined my estimated times for each task. After I completed my project, I created an updated Gantt chart and an updated production table to see how long each task actually took to complete. Time. The second section I'll be talking about is time. It took to complete the project and about the time frame that I set out during planning. The Gantt chart and production table that I was talked about in previous paragraph shows how long each task should take to complete, which allows me to follow my estimated time frame that I had planned for the client. It was difficult to follow my chart and table exactly. This was due to my times only being estimates. Some tasks took longer than anticipated to complete and others took less time to complete, but overall I still completed the project on time. During production, the time wasn't an issue because I planned out my project very thoroughly, which also meant that the time didn't affect the implementation of the project because I had all my time planned out for each task. Focus. The next section is focus. During the production of the project, I found it quite easy to stay focused on the task. This was mostly down to enjoying creating my system and project. My Gantt chart and production table was also helped with the project, but this because I could just check back to see what task is next or what task I should be focused on at that given time. Software. The software that I used to create my system was EasyBuilder Pro. Before deciding EasyBuilder Pro, I researched other software packages which are on the market to see if these met my needs better. I looked into the Rockwell PanelView system and the Siemens Simatic HMI system, but in the end I went with EasyBuilder Pro because I had some previous experience with the software and I also felt that it was easiest to use and understand for novice users like myself. During production I had some problems when it came to using the software, the main one being trying to get my addresses working for the HMI, but I persevered and got it working, and in the end the finished product came out very well and professionally. Hardware. The next section that we'll be talking about is hardware that was used to create the final project. When finding out what hardware I would need for my project, I did a lot of research on the internet. Once I had decided on the hardware I would need, I put it in the table and priced each individual part to make sure it was all in budget. Overall, I had no problems when it came to the hardware. And finally, finished design. You can see an image of my final HMI design to the right. Software. In this section, I will be talking about my experience using EasyBuilder Pro during the production of my HMI system. EasyBuilder Pro, which is also known as Wienentech HMI, is an HMI design package which is perfect for novice users like myself when it comes to creating or designing their own HMI system. One of the main appeals of EasyBuilder is an excellent user interface which can be used by almost all users with very little practice. Another useful feature of EasyBuilder Pro is it is compatible with over 300 communication devices. It can connect to PLCs, servos, inverters, temperature controllers, barcode scanners, and a magnitude of other devices and systems. The final useful feature of EasyBuilder Pro design package is that it's free to download for any user. This is probably the most appealing feature because it means it's perfect for novice users or brand new users who have never used an HMI design package before. I had problems with the addresses and trying to get the system work how I envisioned it. It took time and a lot of work, but eventually I figured out the system and got my program working correctly. It was very rewarding working through these issues and overcoming these to create my final system. Hardware. Hardware is the physical equipment that I have used during my production of my project. In this case, it's the PLC that I have used for my project. The PLC that I have used is the Do More Designer. The Do More Designer software is predominantly a programming software, but it comes with a built-in simulator. The built-in simulator is useful because it treats the simulated PC as a real physical device. This means the user has to connect to the simulated PLC as if it was a real device. write a program and set the device to run. Basically treat the simulation as if it was a physical PLC in their hand, which is very useful because it allows the user to get comfortable with the PLCs without needing a real one. The DoMore Designer Simulator software is also equipped with comm lights. These are found on physical PLCs to show the program is communicating with the PLC correctly. They serve the same purpose on the simulator, which adds the authenticity of the software. During production, I thankfully didn't experience any problems when it came to my hardware. This is why I would recommend this PLC again to anyone who is making a product and wants a reliable PLC which isn't too difficult to use and program. Main areas for improvement. In this section I'll be talking about the main areas that I would improve if I was to do this project again. The first is HMI addresses. As well as this project is gone, there is always room for improvement, and that's why it's very important that I can reflect on my project to identify areas that I would change and improve the overall production of the project. When creating my HMI design in EasyBuilder Pro software, I had a lot of problems and issues when it came to HMI addresses. EasyBuilder is a great software package and was ideal for my product, but because I'm a novice user at best, I found it difficult to get my designed project working properly. In future, I would do more research into the addresses to find out how they work and get a better understanding. This change would help me in the future getting the system to work correctly as intended. The second area of improvement is the professional layout. When creating my HMI design on EasyBuilder Pro, I had to give my design a lot of thought and consideration. This was down to wanting to create a professional design and layout for the client, because first impressions are very important. When creating the system, it has to look professional, because the system could be very good, but if it doesn't look professional and appealing for the client, they won't want to use the system. I think if I was to create the system again, now my design could be better, especially now after receiving some experience in the field. Conclusion. Now that my project has come to an end, this section is just to be used as a final breakdown and final feelings towards the project. Looking back at the project, I wanted to reflect upon aspects such as time management and software that I used. During production, I feel that my time management was handled very well thanks to my detailed planning before starting the production. I also feel that the software that was used, EasyBuilder Pro, was the perfect design package for my system, and I feel overall that it turned out very well in the end. Overall, I feel that my project was very successful and I couldn't be happier with how it turned out in the end. There were hard points during the process, but I worked through these issues and feel good about the finished product. We have come to the end of my presentation. Thank you for listening. If the audience has any questions, I will hear them now and I will try my best to answer them. Thank you again.